Hi everyone. Welcome to our new and last unit. The current unit that we're working on is called Earth's Changing Climate. Um, the title of the unit is very close to something that we've talked about before and that you hear on the news quite frequently, and that's climate change. So we're going to be talking about what goes on Earth's planet as things become different and what happens to the creatures and other living things on the planet as these events are occurring. Today is lesson 2 of chapter 1 because, again, lesson 1 is the pre-test. So this is unit 7, chapter 1, lesson 2. You should have already entered in to the Amplify and website. Make sure again that you log into Clever before you try to click on the link. It will make your life very easy. However, if you didn't and you didn't get sent to the right page, this is unit 7. You can actually scroll all the way to the bottom. It's the last unit, chapter 1, lesson 2. For the warm-up, you're going for each statement in this anticipation guide. Anticipation guide means kind of like we're kind of presenting you with some ideas that you might learn more about during the unit. So what we're asking you to do is to indicate whether you agree or disagree with the statement. You're welcome to add more notes or examples of what you feel might be relevant to the statement. I'm going to read some of them out loud, but before I do that, I want to explain that the expectation is that you will respond to the statement using what you know right now. It is not, we are not expecting you to know the answers. We're just expecting you to give your best guess based on your knowledge. So look at number 1. It says, Earth's atmosphere is made of different gases that can affect Earth's climate in different ways. Number 2, climate has to do with how much energy is in the Earth's system. 3, Earth's atmosphere does not change. 4, there have been times in the past when Earth's climate was very different. 5, energy from the sun that enters the Earth does not leave. It is possible for gases number 5. It is possible 6. It is possible for gases in the atmosphere to change the behavior of energy on Earth. Number 7, human actions cannot change Earth's atmosphere. And the last one, number 8, humans' actions can lead to a decrease in Earth's temperature. At this point, you should pause the video, go onto the Amplify website, which I will show you. If you go onto the Amplify website, one moment, you should be on this page and you should see all of them. It gives you plenty of space to type. You don't have to use all the space. You can simply write agree or disagree. And I'm just going to write answer. And when you finish all of them, return back to the video. But before you do that, make sure you press hand in and click on to the next activity. Okay, welcome back. We're not going to review the answers to these questions, but you will be reviewing them later on at the end of this unit. So this unit question is, what causes climate change? Now, before we can answer what causes climate change, we need to figure out what is climate change. So climate is the general weather pattern over a long period of time. Remember, weather refers to a singular time and place, whereas climate refers to that area's weather over a long period of time. Now, climate change, if we go down to the second definition, is changes in climate over a long period of time that can be caused by natural events or human activities. Now, in the definition of climate change, it gives us a cause. It's either by natural events or human activities. So already we can answer this question, but that answer doesn't actually give us any examples or any evidence to support us. So we have what causes climate change. So we have natural events or human activities. So what we're really looking at is what type of natural events can cause climate change, or what type of human activities can cause climate change. And you can always go back to your vocabulary list from the vocabulary quiz lesson to look back at these words. We're going to spend some time watching a video.
I'm Dr. Derek Lampkin. I'm an ice and climate researcher, and I study how large ice sheets respond to a warming climate. An ice sheet is a large block or mass of ice that covers an extensive area at the size of a continent. I spend my time thinking about the Greenland ice sheet. We're seeing 300 billion tons of ice being lost annually from the Greenland ice sheet. That's ice mass being dumped right into the ocean and making a direct contribution to sea level rise. So we're very much concerned about what the long-term health of Greenland is going to be. When you look at a large block of ice like Greenland, it might appear to you as if it's not moving at all. But it turns out that ice moves very slowly. The ice sheet moves from the center to the edges like a conveyor belt and breaks off into large blocks, which go into the ocean and melt. What we're most concerned about in a warming climate is how fast that ice is moving to the edges and how much contribution the ice is making to sea level rise.
Here's the inside of one of the main tents at Swiss Camp.
I just got back from the Greenland ice sheet on a research expedition where we use GPS to monitor the movement of the ice. GPS operates just like it does in your car. It tells you your accurate location on the Earth's surface at any moment that you're moving. So we use the same kind of technology, but we connect it to poles that are frozen into a fixed position on the ice surface. And then as that ice moves, the pole moves, and we're able to monitor how fast that pole moves. Our data showed us something actually quite exciting. The ice was moving faster when there was more surface meltwater present in the summer. I became very much interested in understanding how much surface meltwater is being produced, how it flows across the ice sheet's surface, and how it makes its way into the ice sheet. Your job will be to help us map out these blue dots, which you can clearly see in the satellite image here. My students help me do this by utilizing images collected from satellites that are in orbit that take pictures of the Earth's surface. What'll look like maybe one channel is actually a network of interconnected. We're able to identify where the lakes are, where the channels are, and we can map out and understand how much they change and how much water they deliver into the ice sheet and its impact on the ice movement towards the ocean. Greenland has contributed over the last decade about 8 millimeters of sea level rise. It doesn't seem like that's a whole lot, but it matters under circumstances where you have hurricanes and storms slosh water onto the land and inundate coastal areas. The more the public understands how these ice masses influence their everyday lives or will influence their lives in the future, the more they'll have an understanding about how to impact policy so that we reduce the impact that humans have on the climate.
All right. So In this unit, your role is going to be a climatologist. I put the two pictures here. One represents climatologists who study different climate changes and weather patterns around the world, whereas a cosmetologist is someone who does any beauty maintenance for people. So that would include hairdressers, makeup, or even eyebrows and stuff like that. They're very easy to mix up when you're speaking, but please make sure you understand that we're talking about climatologists, which study the Earth's change of patterns, weather patterns. So the organization we're going to be focusing on, World Climate Institute, it is fictional because for legal reasons we can't use the name of the real organization, but it's very similar. And if you search World Climate Institute, I'm sure you'll find the real one. Their logo and stuff does look like ours, but we can't use theirs for legal reasons. Now, this organization and the organization, the fictional one we're going to be using, their main job is to research the causes of global climate change, educate the public about climate change, and mentor student climatologists. So you are going to be one of those student climatologists. And our first letter is from Irene Lee, and it's really a welcome letter. The World Climate Institute is pleased that you will be assisting us in reaching out to the public in explaining a complicated process, why the ice on Earth's surface is melting. To help you, you will need to learn how energy moves throughout the Earth's system and how this is related to temperature changes across our planet. This is complex but important science, and explaining requires a complex understanding of the entire system so you can make sense of it for others. Only then will you be able to explain what is happening to our planet and why the ice is melting so rapidly. So we are at our final unit, and when we started in the beginning of the year, we started with human energy. We have used the term and looked at all of the processes of, many processes of energy on Earth. So what we're going to be doing in this last unit is using all the information we know about energy through thermal energy, through biosphere energy, learning about weather energy, and learning how all of these together can help us explain how the ice is melting and affecting our planet. Your goal by the end of the unit will be to thoroughly answer the question of why the ice on Earth's surface is melting. To do this, you will need to learn as much as you can about Earth's systems so you can understand the changes we are currently seeing in Earth's climate. This is real. We are seeing this every day. This is currently happening and is something that you and future generations will have to deal with. So let's analyze this claim. The amount of ice at Earth's poles is decreasing significantly. The first task is to review the data collected about ice melting or decreasing at the poles. There was evidence about climate change in the video, and it is important to be skeptical and review data carefully. So the evidence in the video that they used was that they used poles and measured how far those poles moved while the Earth's ice was continuously moving. We call these glaciers or ice sheets. You might have seen them either way in your social studies and previous science classes. So before we begin, we have to look at what's going on with this science. And previously, in the past, this was not an accepted truth. And even today, a small percentage of scientists still don't believe this. 99% of scientists believe in climate change, but we have to question, why did some scientists initially disagree that the overall ice was decreasing. When we look at data, we have to look at why some people might be skeptical of data and making sure that the data we're using has a significant amount of information. We saw this when we did when we worked on the parrots in one of our previous units, and talking about how certain data is more convincing than others. And the general process we found, explanation we found, was that the more detailed the data, the more locations, the more years, the longer the study, or the widespread of the study, gave us better data. So we're going to look at this data right here. And this is evidence card A. You're going to get 3 pieces of evidence, and we're going to review them today. So the title is The Amount of Summer Sea Ice in the Arctic. Again, we're looking at some important things. The title of the graph tells us that it's happening over the summertime and that it's happening over 11 years. Summertime would be a significant time to look at melting ice, as that is when it's getting direct sunlight, or closer to direct sunlight. Now let's look at the labels of the axes. On the bottom, we see that it's labeled in years. Again, the lowest year starting in 2002, and the last year looks like it was recorded in 2013. Again, 11-year span. On the side, on the y-axis, it says million square kilometers of ice. Now, knowing what the axis is measuring is important, because if you look at the first number, it looks like it's 6.5. 6.5 going down even to the lowest at 2012 to 5.5 is only a difference of 1. But knowing that this is being measured in million square kilometers means that it went down 1 million square kilometers. So keeping data of what it's measuring, how it's measuring, and when it's being measured is an important part of picking solid evidence. Now, let's take a look at 3 pieces of evidence, A, B, and C. We already evaluated A, but let's take a look at B, which is the middle image. And it says the amount of summer sea ice in the Arctic 1980 to 2013. Now, if you look at the difference between A and B, you can see that B seems more dramatic. The decline is much more vivid. And this is simply because we're looking at a longer period of time. Now, if we look at C, which again is the amount of summer sea ice in the Arctic, but if you look at it, it gives us an image that there is a 1 decrease in 1940 that seems really significant, and then it proceeds to drop exponentially from 1980 to 2020. Now, C and B are better evidence than A when we talk about understanding how ice is moving. But evidence A shows us why some scientists might have initially disagreed. So if they're looking at evidence that was simply for a short period of time, they might not have believed the evidence, which is why it's important to give people multiple sources and multiple and longer studies to give them a bigger picture of what's going on. Now, we're going to go to a new piece of data. In this, you see that it says the global average temperatures between 1880 and 2009. So there are two different types of things we look at when we talk about data. One is the trend. On average, which way is the information going? Is it showing an increase, a decrease? Is it showing that it's stable? And if you see the blue line, that's the line of trend. It tries to follow best it can along the data points, finding the average between the years and just moving up and down. You'll see that the trend is showing that the temperature is increasing. The second word is fluctuation. Now, this is various sets of data. Now, what it's saying is that it's showing that every year it goes up and down, that it's not always going in the same direction, which might be why some people may not have believed this science in the beginning, because they were seeing that the temperatures were simply going up and down. Because of the fluctuation, it may not look as dramatic, but if you take a longer period of time or study, you will see that the trend is that it's continuously going up. Yes, some years it goes down, but for the majority, or for the trend, it is going up. Now, the circled area shows us the years between 1940 and 1970. If we look at the prior data, that would be just around the time that the ice, that was just before, the years 2 decades before there is a significant decrease. If we look at evidence B, that we would say that from 1880 all the way to 1940, the trend is that it's not changing. 1940, quick decrease, and then again an increase back in the 1950s. But from 1980 all the way to 2020, we are seeing that the data shows us that it is a direct decrease trend. But the fluctuation might have made it so scientists may not have believed it. But on a longer period of time, you can see the trend shows that the temperature is rising. So if we go back to the claim, the amount of ice at Earth's poles is decreasing significantly. We can see from evidence C and evidence B, the two stronger pieces of evidence because it includes more time, that the trend is that the ice is melting, that there is less ice in the Arctic during those years as the years progress. So the claim would be supported by B and C. If somebody was to use evidence A, you can actually argue that the claim is incorrect, which is why some scientists initially disagreed with this, because they were looking at a data set that was not complete. So, although there are many fluctuations, there is a trend towards increasing temperatures and decreasing ice on Earth since 1880. Now that we know that there is some type of event going on that's changing our climate, we got to see, what does this mean? Why does it change? And how does energy play a role in how Earth reacts to all of the new things happening on its planet? We're going to continue about this conversation. Tomorrow you are to finish your reading quiz, which is lesson 42. For this lesson, you should have only submitted your warm-up. Thank you.